my name is Yorke. I'm a research scientist in Pasadena, and I will be talking about how to calculate the force on a Kelvin balance. A word of warning, this is not for the faint-hearted. Let me define some of the terms. The length of the coil is L, the radius of this coil for the electromagnet is R, and the number of windings are N. Now, we know that when current flows through this wire, it produces a magnetic field, which is given by the expression B, the magnetic field, is equal to mu naught, that's a physical constant, times the number of windings times the current divided by the length of the coil. And the force between the two coils is approximately given by this expression. I'm not going to read it all out, but it depends, of course, on the B, the magnetic field, the area of the coil, and things that we can determine, including the distance between the two coils. Now, what this means is I can work out for the top stop and for the bottom stop what this expression is. And it turns out that the force that is between these two coils will depend on whether we're in the top position or in the bottom position. So I can work out the constant for the top position and the bottom position. And it's also proportional to the current squared. The force given by the mass, which is trying to, of course, these attract each other, and so it's trying to pull this down, and so I need the mass to balance this. The force given by this mass is the gravitational constant, G, times the mass, M. So this gives you the weight. And I've imagined that my mass can be moved along here at a distance small d from my pivot point. And so what I need to do is to move this mass, if I'm in the top position, to the left so that this force that is keeping it up decreases, and then it'll flip and go into the bottom position. I measure that distance, and I can now determine the current by using this equation. It sounds complicated, but it'll work. And just to test whether or not you're getting the same answer, when you're in the bottom position, you can then move the mass towards the right until it flips back into the top position. Of course, you have to use a different constant. And when you have those two numbers, if they're not the same, then what you would do is either average the two, or you would probably think that maybe this formula is not quite right, which is true. The formula is only an approximation. And it would be better if you could actually use in this circuit known voltage, known resistance, and to know then what the current is, and in this way determine what your constants are for known resistance and known voltage. Now, once you know these constants, you can then vary the voltage and vary the resistance and measure the current. So, have fun doing this. Thank you.